But Sundar, you were, if I look what has happened in technology over the last, I would even say 30 years, there was one big breakthrough. It was actually when AlphaGo was beating Lee Sedol. I think we haven't really understood yet the implications of this breakthrough. And now your company, Google, is again at the forefront of another revolution, which may have even more consequences, positive or negative one. It's actually what you just announced in quantum computing, the breakthrough. And I have to say, it's very difficult to understand. I just know it could have tremendous implications. Can you explain what we can expect from quantum computing? And you are now the leader. You have made the big breakthrough.
No, it's an extraordinarily important milestone. Last year we achieved something what's known in the field as quantum supremacy. It is when you can take quantum computers and they can do something which classical computers cannot. I like the way you characterized it. It's as inspiring a milestone as the Deep Blue moment or AlphaGo playing with Lee Sedol. To me, nature at a fundamental level works in a quantum way. At a subatomic level, things can exist in many different states at the same time. Classical computers work in ones and zeros. So we know that's an imperfect way to simulate nature. Nature works differently. So what's exciting about quantum computing and why we are so excited about the possibilities is it'll allow us to understand the world in a deeper way. We can simulate nature better. So that means simulating molecular structures. So maybe we can discover better drugs. Understanding climate in a deeper way so that we can predict weather patterns and tackle climate change. We can design better batteries. Nitrogen fixation, which is the process by which we make the world's fertilizers, accounts for 2% of carbon emissions. And the process hasn't changed in a long time because it's very complicated. Quantum computers one day allows us the hope that we can make that process more efficient. So it's very profound. We've all been dealing in technology with the end of Moore's law. It's really revolutionized the past 40 years, but it's leveled off. So when I look at the future and say, how do we drive improvements, quantum would be one of the tools in our arsenal by which we can keep something like Moore's law continuing to evolve. So the potential is huge, and we'll have challenges. In a 5 to 10 year time frame, quantum computing will break encryption as we know it today. But we can work around it. We need to do quantum encryption. So there are challenges, as always, with any evolving technology. But I think the combination of AI and quantum will help us tackle some of the biggest problems we see.